Hello everyone, I'm going to take you through the LayerZero v2 CLI. If you've seen my previous video, this tutorial is going to take you through a lot of the same steps, but it's going to be a lot simpler because we'll have the CLI. And also another difference is that in the previous video, I took you through an example of general message passing, whereas in this video, we're going to be using the omni-chain fungible token example contract, which is going to involve the transferring of an ERC20 token across chain. So the CLI is actually an NPX package. You have to use NPX. You can't use PNPM or Yarn. Great. So what you can expect from this tutorial is you'll be using the CLI to deploy contracts on two separate chains. You'll be linking the contracts to each other to allow for the message passing, which is required. And of course, we'll be testing by sending a message which involves the transfer of the tokens. Okay, before we hit the CLI, let's go through some basic concepts. So within the LayerZero universe or ecosystem, they use the terminology of omni-chain application and omni-chain fungible token. So in the documentation, if you see OAP, it stands for omni-chain application, and it's just for generic message passing. But if what you want to do is to support the transfer of ERC20 tokens across chains, then you want to refer to resources that mention OFT, which stands for omni-chain fungible token, and that's ERC20 compatible. So O stands for omni-chain. Okay, so we're gonna run the command in a bit, but another terminology that I want to introduce to you so that you understand better what's happening is connections. This was not mentioned in the last video, and it seems to be a new term that's popping up in the documentation. It's essentially referring to the allow listing of contracts. So in order for a contract on one chain to send a message to another chain, they need to allow the other contract, right, to establish a pathway. So from Avalanche Fuji here, for example, there needs to be a pathway to Polygon Mumbai, and from Polygon Mumbai to Avalanche Fuji. And in order for that to happen, a particular method on the contract needs to be called, and that is the setPeer method. And LayerZero seems to be using the terminology of wiring to refer to the act of connecting the contracts across chains. So the CLI uses the term wiring. So to wire two contracts means to allow lists themselves to each other. So let's hit the CLI from the official documentation, whose link I will be including in this markdown that I'll link to in the description of this video. We can copy the command. We hit terminal. I'm going to go with the default project name, directory name. And over here, we want to select OFT so that it involves an ERC20 token that can be transferred across chain. I'll use the recommended package manager of PNPM. And I'll just hit yes here to confirm that I want to install the dependencies. So a thing to note here is that this pretty much assumes that you're deploying the contract on the separate chains from scratch, right? This is what the example contract or project is. Great. So now that that's installed, I'm going to open it up in my VS Code. And we can see that we have these standard folders. The contracts are in here. And we have also a hardhat.config.ts and also a layerzero.config.ts. Okay, so let's head back to the diagram. Now, the example gives you 3 networks, but in order to make this process less annoying for you, we'll stick with only Avalanche Fuji and Polygon Mumbai. For some reason, Sepolia Testnet Ether has been a bit hard to find, to obtain recently, so we're going to stick with Avalanche Fuji and Polygon Mumbai. So what we want to do over here is to head over to LayerZero.config.ts, and you can see that over here we are specifying the connections that I was referring to earlier. We have the hardhat.config.ts, we have the LayerZero.config.ts, and also .env file. So these are the configuration files that you want to pay attention to. Because we want to remove one network from the example, we need to modify the hardhat.config.ts and LayerZero.config.ts. So inside LayerZero's config file, we want to comment out Sepolia. Okay. So everything that mentions Sepolia, we'll comment it out. So effectively, now we only have a pathway from Fuji to Mumbai and from Mumbai to Fuji. And then we'll want to go to hardhat.config.ts as well, because the LayerZero CLI reads the values here and takes into account the networks that are mentioned here. So let's just remove Sepolia so that it won't even ask us for it. And then, of course, you would need to input your private key. So copy the example.env file, rename it, and you only need to fill in one, right? So I'm going to fill in private key. I'll use the magic of video editing so I don't expose my private key to you. Okay, I've inputted my private key into the .env file, and at this point, you need to make sure that that address has native gas tokens. So because we're using Avalanche Fuji and Polygon Mumbai, you need testnet gas tokens on both those networks. I'll be linking to the Avalanche Fuji faucet page and also the official Polygon faucet page in the markdown. Right, so if we go back to the project that the CLI helped us set up, you'd see that the contracts repo has a myoft.sol and myoftmock.sol. And if you observe them, the relationship is that myoftmock derives from myoft, this one. And the only difference is that myoftmock adds a mint function, which is needed if you want to test the transferring of tokens, right? Because if you can't mint, then you can't transfer anything. Because I'm lazy, what I would do here is I would just call the mint function actually and send it to the deployer of the contract. I'll modify this to send 100 of the token. And the deploy script actually would deploy the myoft. So this is by default it would have this, but you should change it to this so that it would deploy myoftmock. So myoft is pretty much a starting point if you wanted to actually deploy your own contract, right? You use this as a starting point and you would add in whatever else that your contract would need to support. But if you see OFT, you'd see that it is an ERC20 token. Okay, so great. Now that we understand what contract will deploy, and I'm assuming that at this point you already have the testnet tokens, we can move forward with the deployment. So from the official documentation, it's a hard hat task that we're running. And you can see that it's listing Fuji and Mumbai here, and it doesn't mention Sepolia because we've commented it out from our hardhat.config.ts. So if you want it to deploy to a network that's other than Fuji, Mumbai, Sepolia, you need to define it here. And you need to specify the EID and also the RPC URL. Okay, so it's already selected Fuji and Mumbai. So I only need to press enter at this point and deploy script tag. So this is referring to the tag that's defined here, and it's the contract name. So it's my OFT mock because we've already edited it. If you don't edit it, it's going to deploy this contract, and that's not going to allow you to mint anything. Okay, so I clicked enter, so it's going to deploy, the only contract. If we had multiple here, then if you don't specify the tag, it would deploy all, depending on what you want to do. Okay, so it is now deploying to both those chains. And just like that, the contracts are now deployed. So you can see here that on Mumbai, it was deployed to this address. So if we go to mumbai.polygonscan.com, we'll see that, hey, yeah, so we did deploy this contract. And then on Avalanche Fuji, you can use testnet.snowtrace.io. And you can see that also it was deployed. And on both these networks, because we had modified the constructor to include this, that means already on both exists 100 of the tokens. So if you were to send, for example, 100 from Fuji to Mumbai, then Fuji would end up with 0 and Mumbai with 200. Great. We've deployed the contracts, and how easy was that, right? Using the NPX package. The next step after deploying is wiring. So at this point, we have the contracts, but they don't have these pathways yet. So you're not able to send messages. So we need to wire them. And as mentioned earlier, it's under the hood essentially calling set peer. And the command to run is this. So you can also run this if you want to get more information on the configuration. Because in the LayerZero.config.ts, you can actually specify a lot more things, but we didn't. We're just going with the defaults. But if you run this, you'll see that we have these configurations that we didn't specify, so they just went with a default. So if you're already familiar with the DVNs, you're able to specify required DVNs and also optional DVNs. I won't get into this in this video. Okay, so let's copy the wire command. So something that is currently missing from the official documentation, but you would need is a flag for the path to the config file. So you can see that currently the CLI would complain about it. So we just need to do this and also specify the config file. And another thing that we need to do is actually, because we deployed not my OFT, but my OFT mock, we need to edit these values too, because the CLI is going to look for the contracts based on the names that we've specified here. Cool. We can click on Y to see the configurations. You can see here that for the Avalanche Fuji contract, the address is as what we've seen before, and the endpoint ID for Polygon V2 is going to be this, and the address. This is something that we had to manually do in the previous video, but the zero padding is done for us automatically. So the CLI is really helping us a lot here. And down here as well, you can see on Mumbai, it's the Versa of what we saw. So Avalanche Fuji's endpoint ID is here, and over here we are, sorry, this is the contract address, but then this is the just the data for the transaction itself. You can see that it ends in the address of the contract. Okay, so everything looks good. Yes. And it's going to call set peer for each of the contracts. Again, you can see how much simpler this is as opposed to having to switch between networks and play a game of jumping back and forth. So the OAPs or OFTs are now configured. The contracts are now wired. So because we'll be using the Explorer to test the sending of the message, we want to verify the contract first. So we'll do, with the test, we'll do from Mumbai to Fuji, simply because verifying a contract is more straightforward on Polygon Scan as opposed to Fuji, which doesn't support it via the UI. So what we want to do is click verify and publish over here. The compiler type, we should select standard JSON input. Compiler version per what is specified in the hardhat.config.ts. Select MIT. Continue. And over here, you want to select the file that's under deployments. And because we're verifying the Mumbai contract, and you want to select Sol-C inputs. And this is the standard JSON input that you want to use. So we're going to choose a file here. We have to click on this button to upload the file. Prove you're not a robot. And then click on verify and publish. Great, so the contract is now verified. You can click in here to see the contract. We can see that it has indeed verified the source file. Okay, so to proceed to the next step, we want to manually test the sending functionality, right? And just as a refresher, if you've seen the previous video, when we want to send a message, we need to first find out how much of the gas token we need to supply to the sending function. And for that, we got to call quote. But then in order to call quote, we need the params or the options. So this will be clearer if we actually open or view the send function. So this is, we want to click on write contract, send. So this is the amount that you want to include, and this should match the amount given by the quote function. And of course, for our purposes, we're not going to include the native drop option. We're not going to include the native gas token to be dropped in the destination chain. So it'll just be the gas needed for the sending of the message. So there's a bunch of parameters here, and in order for it to be a bit clearer, we can go to the source file. From here, we go to OFT, and from here, okay, it's inside OFT core. Send param, right? It's this one actually. This is the interface that we need to refer to, but just to, oops. Okay, yeah, I'm jumping the gun a little bit here because I'm already talking about quote send. So these are the params, but in order for you to know how much to send, you need to call or use the quote send function, this one. But this is a tuple, and this is the interface or struct that I want us to view right now. So this one, you can see the send param and pay in LayerZero token. For this, we're just going to go with false because we're going to pay in the native gas token. And here you can see that the params are destination ID, the to address. This is the address that you want the tokens to be sent to, the amount, min amount, and the options. Compose message, we won't specify anything. Compose is when you want to call another contract in the destination chain. And this is just an example argument that's actually not used anywhere. Okay, so destination endpoint ID. So from Mumbai, we want to call Avalanche Fuji, right? So the endpoint ID is this one. Like so. And next is the to address. It has to be 0 padded. So I want to send this to my own address here, but it has to be 0 padded. And I'm just going to copy the number of zeros here. You can see that, this is referring to, this is a 0 padded address of the contract on Mumbai. This is the right number of zeros, which is 24 for 12 bytes. Okay, and then the amount will go for let's see. So I normally use eth-converter.com. Ooh, I don't know what happened to this. Like, they've put in just today ads. Okay, let's try sending 10. So in way, that will be this number of zeros. And I'm going to put the same for min amount sent. So options, for options, we need to use the options builder from LayerZero. Okay. So over here, so we have two options for building options. Either use the Solidity contract or a npm package. So because we just want to hack things quickly, we'll use the remix contract. And if we focus on options generator here, so you want to just deploy it to the remix VM. What we want to call is create LZ receive. Okay, we don't need compose and combine. So when it comes to options, you have LZ receive, LZ compose, and LZ native drop. So LZ receive is the plain one that you want to use. LZ compose is the one that you want to use if your destination contract needs to call another contract. And native drop, as I've mentioned, is if you want to send some gas token in the message sending. But we don't need all of that, so we just want this. LayerZero's recommendation is to put 200,000 for the gas value. And because we're not sending any value with our message, aside from the tokens, this is going to be 0. So this is going to be the value that you need to pass in as the next argument. This is the options argument. And for the next two, compose message and OFT command, we don't need them. So we're just going to pass in an empty byte. Okay, so I've noticed that for testnet versions of Etherscan's website on other networks, you might need to connect your wallet first before calling in a read function, because I guess they're using the provider of your wallet as opposed to their own. loading because of the public RPC not responding, so I had to change to a personal one from Infura in order to get a response. And what you want to get is this one. This is the value that you need to send in order to successfully send the message. But this is in wave, so we want to convert it. And I'm not sure why the gas recently is incredibly high. When I was testing this a couple of days ago, last week, it wasn't this high. Okay, so we want to copy the parameters here. The amount, the to address. Oops, so that one is the to address, and destination ID is there. And the amount is going to be the same. The options, it's going to be empty. Okay. And that has to be the same value here. And LZ token fee is going to be 0. Refund address, I'll be putting in my own address. Oops, gotta click on connect. And I'm just gonna top up my address because I don't have enough Matic right now. I need just a little bit more. So I will fast forward as well. Okay, so now I have more than enough testnet Matic to call the send function. So if we wait a few seconds, copy the transaction hash and go to the LayerZero scanner. Okay, so around a minute later, we're here. You can see that the message has appeared on LayerZero scan, and the cargo here is specified. This is the number of tokens that we are sending, and that one was based on the amount LD input that we specified earlier, the min amount. And over here, okay, this UX I find a little bit confusing because it's specifying the 0 address. So I don't know if this means that, you know, we're signifying that this was a burn and mint, perhaps. But you can see that, hey, it was sent from Mumbai to Avalanche Fuji. And if we go to the contract on Avalanche Fuji, you'll see that, yeah, 10 mock OFT token was sent to my address. So you can see that I have 110. This was from an earlier test that I did, but from this one that we're doing, I now have 110. I started with 100 and I sent 10 across chain thanks to LayerZero. So that's pretty much it. I hope that was useful. If it was, and if you want more, click on subscribe. Thank you and have a nice day.